Hi students, welcome back. So today I'm going to take some problems on logic gates and we will try to solve them. Okay, and these are the common problems that you can see in your question paper. So the first one is very simple. If you have already studied and you know it, it will be very easy. But for those of you who are trying this for the first time, this problem is actually very simple. What you have to look at is the input that they have shown us and the output. Okay, so we will do a truth table with the values. Remember that for a wavefront that they're showing here, each level, okay, this high level will be called as 1 and the low level will be given a value of 0. So we will put our input values. Let us write input and our output, which is given as y, and let's start writing the values down. So if we see that the first one, the input value is at the 0 level, so answer will be 0 here, but the output level is 1. Here the input level is 1 and the output is 0. Then the third one is input is 0, output is 1. Then yes, input is 1, output is 0. Then again input is 0, output is 1, input is 1, here we are at this stage now, and output is 0, and last one is input is 0 and output is 1. Now we have a fair idea what this gate could be. Okay, so looking at our input and the output, this truth table might be very familiar to you if you've gone through my previous videos. Okay, this truth table is nothing but the table that has these values a, y. 0 is giving you 1, and if the input is 1, it is giving you 0. So which is the truth table? Which gate would this be? Yes, it is the NOT gate. If you are asked to draw the symbol, then you will draw the NOT gate symbol, A and Y. This is how you are going to solve this kind of a problem. Okay, this is the basic. Now we will take a little bigger problem where you have to, work a little more. I'm just going to increase the size of this font so that you can see. Okay, the question is very simple. We have been asked, let me just put it out here. Yes. So the question is, the following figure shows the input wavefront A, B and the output wavefront Y of a gate. So we have been told that these are the values of the input and the output. We need to identify the gate, write its truth table and draw its logic symbol. Okay, and draw its logic symbol. So let's start. The first thing you would do is to draw the truth table because the values are given to you for this problem. So let us start writing the truth table. Okay, we will write A. There are two values for this gate. So there are two input values A, B and Y. Yes. So let's make a truth table. Now make sure you draw the truth table and write all the values. Okay, so let's start the first one here. This is the high level, so input will be all 1 when it reaches high. This is going to be 0. At this it's going to be 1. This is going to be the 0 of it. Same way this is going to be 1 and this is going to be the 0 of it. If you are confused, you can write this at the side so that it's easier for you to write down the truth table and start the problem. Okay, so the first one, we can name them if you want so that you don't get confused. These sections you can put numbers. This is for your better working. If you are able to do it faster, it's better. So let's start. The first one is input at A is 1. Input at B is also, yes, it's 1. And the output is shown as a 0. Good. Then we have input as, at the second point, it is, yes, it's 0. Input at B is also 0, but the output is shown as 1. Then we have the third one. Third one has 0 input at A, 1 at B, and output is 1. At fourth one, it is input as 1, output as 0, input at B as 0, and output as 1. Okay, you can continue further. I'm giving you a minute now. You can complete this. I will start in a few seconds. Yes. So we have finished the first, the second, the third, the fourth. Now we will do the fifth, sixth, and the seventh one. You can also write it like this so that you are not confused. Okay, so let's do. Check if you've got the answers correct. For the fifth one, A is 1 and B is also 1. And Y, the output is 0. 6, input is 0. B is at 0. Y is at 1. At 7, it is at 0. B is at 1 and Y is at 1. So here we have written the truth table. This is the first step for us to solve this kind of a problem. Now, for us to make it simple, we need to identify the gate. So this is a lot of values. What you're going to do is you can just make another truth table here with A, B and Y. Now I'll tell you why you need to do this for easy working, okay? You know that the combination of all the truth tables is 0, 0, 0, 1, 1, 0 and 1, 1. Now that you have the combinations, you search for the answer. In this setup, where is the 0, 0? At 2 here. So 0, 0 is giving us 1. So you will write the value here. 0, 1. Let us search for 0, 1. Yes, it is at 3. It is giving us 1. Then we have 1, 0. 1, 0 is at 4. It is giving us a 1. And 1, 1. 1, 1 is 1 at 1. Or at 5, you can see both the values are the same. 1, 1 is giving us a 0. So now which gate is this? Which gate gives us these values? Yes, some of you must have recognized this gate. It's the NAND gate. Okay, it's the NAND gate. So we know it's a NAND gate. They have told us identify the gate. Yes, so you will write this is a NAND gate, and you are going to write the truth table and draw its logic symbol. So the truth table is already drawn. These two are here, and you will draw the logic symbol. That's it. A, B, and your gate is done. This is what you are going to do. Now remember, if this is shown as Y, you will write this as Y. Okay, to be more precise. So this is how you're going to solve a problem that is given to you. We have identified the gate, we have written the truth table, we have drawn the logic symbol. Okay, I hope this is easy. We will take one more problem. We'll take this one. I'm just going to increase the size. Yes. Now this third problem is rather simple. It's asking us to draw the output waveform at X. So we have been shown a combination of two logic gates. And they're telling us using the given inputs at A and B for the logic circuit shown below. Also identify the gate. This is what we have been told. Now it's actually very simple. What we are going to do is, first of all, we are going to write the truth table looking at the waveform. So the waveform is here. We will write the truth table. We have A, we have B. Okay, only A and B is given to us. Y we have to find. Okay, the output we don't know yet. That is what we are asked to find. So we have A and B. Let's start. It's already marked for us, so we can do it easily. But for our better understanding, we can mark it like this. Okay, 5, 6, and 7. Okay, start. The inputs are, first ones are 0, 0. Next we have 1 and 0. Then we have third one is 1 and 1. Fourth one is 0. Here we are at this one, 0 and 1. Then we are at 0 and 0. Then we have 1 and 0, and the last one is 0 and 1. Okay, so this is our truth table for now. We don't know what is the output. Now let us look at the symbol, the logic gate symbols given to us. Can you identify this first gate? Yes, it is the NAND gate. Okay, so the Boolean expression for NAND gate is A dot B inverse. So let me write one X value here. Okay, so that means let us say that this is going to be our output at the first gate, and the Boolean expression we have written for us on top. Okay, my lines are very crooked, but let's start. So the value for X, what will it be if the inputs are 0 and 0? 0 into 0 is 0. Inverse of it is going to be 1. 1 into 0 is 0. Inverse of it is again going to be 1. 1 and 1 is 1. But the inverse will be, yes, it's going to be 0. 0 and 1 is, if you put it over here, it's going to be 0. But the inverse will be 1. 0 and 0 is 0. Inverse will be 1. 1 into 0 is 0. Inverse will be 1. 0 into 1 is 0. Inverse will be 1. So that means we know that at X, at this junction, the values that are coming out of this output as in the form of the output are 1, 1, 0, 1, 1, 1, 1. Okay. So with that in mind, now we can split the values here. Okay, so what's happening is this is getting split into two parts. Whatever value is coming out is going into two parts. So for example, now 1 is coming here, so it will get split into two sections. I'm just going to show it for your own understanding. Okay, so if I name this as x1 and x2, okay, then this is going to have x1 and x2 will have values. 1 will get split into two ones. This one will again go as 1 and 1. The 0 will go as 0 and 0. The 1 will go as 1 and 1. 1 and 1. 1 and 1. 1 and 1. So now we know that whatever is entering, whatever is exiting from the first output gate, okay, will go as input in both the input nodes. So that is what we have to remember. And then what will be the output? So let's write the output for the final output. Okay, this is the main output. Okay, I shall draw this line very nicely. Yeah, much better. Let us do the final one, the value for X. Okay, so 1. Before that, you can also write the Boolean expression. This is again a NAND gate. Second gate is also a NAND gate. NAND gate Boolean expression is A dot B inverse. So 1 into 1 is 1, inverse will be 0. 1 into 1 is 1, inverse is 0. 0 into 0 is 0, inverse is 1. 1 into 1, all these values are going to be 0, 0, 0. Now, our problem is not yet over. We have identified what is happening. But our final answer is we have to draw an output wave at x. So this is going to be given to you in the paper same. Then you are going to redraw the inputs. You have to show the inputs and the output together. Okay, so we will draw the input and the output together. So what we can do, we can start marking. We know that there are 6 sections, so you can just put dotted lines like this. You can space them out equally. This is the first, second. Okay. That's it, I think. This is going to be your T1, T2, T3, T4, T5, because since they have named it T6, and if you want T7. Okay, the last one. And now we begin. We know that the first inputs are given to you, so you can draw. A is here. This is like this. 3 is here. At 4 it is down. At 5 it is up. I'm just redrawing the whole thing. And at 7 it is down. At B it is down. Okay, so I will just place it a little lower. It is down. It continues to go as 0. Then it gives us a 1. The fourth one is also 1. We've reached here. Now it's a 0, so I have to go lower. It's a 0 up to 6. Seventh one is a 1. Now looking at the output of our truth table, this value, we will draw the output. So the first one should be a 0. Okay, I'm going to take it a little lower. Sorry. Yes, we are here. I'm going to draw the value 0. Second one is also 0, so we are going to continue to draw 0. Then it is 1. Then it is 0, 0, 0, 0. That's it. Okay, that is it. That is all you have to do. Yes, and if you are asked to identify the gate, then you will draw again another truth table. I'm giving you a few seconds. You can start drawing the truth table, looking at what is given to you. A, B, and the value of x. What you will do, you will write 0, 0, 0, 1, 1, 0, 0, 0. Yes. Please write down. Yes. Okay, so we can find out that at the input over here at 0, 0, answer is 0. So you should have a fair idea which gate this could be. Then second one, where is second one? I can find it here. 0 and 1. Output is 0. Then we have 1 and 0. Where is 1 and 0? Output is 0. And last is 0 and 0. Output is 0. Sorry, I have not written. Oh, sorry, I made a mistake here. This is supposed to be 1 and 1. 1 and 1. Get 1 and 1. Output is 1. Yes. So which gate is this? Where the value of 1 and 1 is 1 and the rest everything is 0? Yes, you're absolutely right. It is the AND gate. So that's it. So if we are asked, I think in this question we have been asked also identify the gate. So this is how you're going to write. It is an AND gate. And if you're asked to draw the symbol, you will draw the symbol. You will show this as A, B, and you will show it as X. It's AND gate. That's it. So this is going to be your way of solving. Okay, and our final gate is going to be an AND gate because we found the values. So I hope this is simple. I will also upload another video of some more problems looking at only the logic symbols. So these are with the waveforms, and the other type of questions that you could get is with the logic symbols. Okay, so thank you. Until then, revise and learn. Bye.